Okay, in this objective, what we want to focus on is we have to focus on different types of fluids in our body. And we're going to refer to these as solutions, as colloids, and as suspensions, each of the three having different properties. And in our body, previously, in at least the discussions I've been having in this section, we've been talking about the fact that your body, plus or minus a little bit, okay, is about 60% of your total body mass is water. So water is very important to us from the standpoint of maintaining balance of water in our cells, maintaining certain substances, the balance of those substances in and out of our cells, all of those things. So what we want to understand is certain things like to dissolve in water. And I think the easiest way to think of this is like dissolves like. It's like, well, what do you mean by that? Remember the water molecule that we've discussed, okay, in depth and probably more than you ever wanted to know? Remember the water molecule consists of polar covalent bonds. And it allows then that molecule to have, on the hydrogen side, being a little bit positive, and on the oxygen side, a little bit negative, because that oxygen is more electronegative than that hydrogen. And so because of that, it has a little bit positive charge, a little bit negatively charged. So things that dissolve in water are things that are charged or charged like water. So ions dissolve in water. Other molecules that have partial positive and partial negative charges, like water does, dissolve in water. Things that consist of polar, non-polar covalent bonds don't dissolve in water. That's why we talk about the fact that oil and water doesn't mix, because it doesn't dissolve, okay, because it's not like the water molecule. So what it creates for us is it creates what we call a solution. A solution is a substance, okay, and it has two parts. It has, and I like to refer to it this way, it has the dissolver, okay, and in the context of our body, that is water, and it has the dissolvee. So the thing that's doing the dissolving and the thing that got dissolved. So we have the dissolver, which in our body is water, and we have the dissolvee, the stuff, like sodium, chloride, magnesium, calcium, all those electrolytes. They're dissolved. So a solution consists of a given amount of stuff, dissolvee, and we call that, okay, the solute. Or if there's more than one type in there, we call it the solutes. So the substances that got dissolved are the solutes. The substance that did the dissolving is called the solvent. Collectively, they make a solution. So if we look at a situation like, all right, if I have a 10% salt solution, or if I have a 5%, salt solution. Apologize for the script there. It's okay. Okay. So if I have a 10% salt solution, a 5% salt solution, I still have two things. I have a solution, and this solution consists of the dissolvee, solute, and the dissolver, the solvent. The solute being the salt, the solvent being the water. Now the water doesn't always have to be the solvent, okay, but again, in the context of our body, that's it. So in this situation, I have this much salt in a given amount of solvent. In this situation, I have this much salt in a given amount of solvent. Obviously, one is, saltier, okay, than the other one. And so it kind of varies by the solution. So, for example, the Great Salt Lake, okay, the salinity, the salt content, ranges anywhere from about 5% to 27%. Okay, in our body, our salinity, okay, when we talk about giving a patient normal saline solution, a normal salt solution, okay, it's about 0.9% salt. So that means I have a little pinch of salt, not this kind of salt content. And there's all sorts of other stuff that's dissolved in our plasma and all the other body fluids that we have. Now they do differ a little bit from fluid to fluid, how much is there. Okay, so when we talk about somebody's sodium level, their potassium level, their chloride level, their magnesium level, okay, we draw blood for those. And so we're actually talking about their blood or their plasma level. Okay, there is spinal fluid and synovial fluid and other types of fluids. There are solutes in those, but not the same levels as the other. Okay, so we do have ranges for those as well. So do keep that in mind as we talk about those. So the question is, well, how much? Okay, and there's different ways we can reference solution concentration, we can reference them as a percentage, and we can also utilize a number that we call a mole, and we're going to get to that here in just a minute. Okay? So we refer to these as percent solutions, and then we're going to refer to these as molar solutions. All depends on how we're measuring them. Okay, so I can have two beakers holding two solutions that have the same concentration, and I can actually represent one as a percent and one as a molar solution. Doesn't mean their concentration's any different. Just depends on how I measured it. For example, remember in our last module we talked about using the English or the customary measurement versus using the metric measurement. It didn't change the volume, it just changed how I was representing that volume. Whether I used ounces or milliliters didn't matter. Well, it would matter if someone liked one over the other, but it doesn't matter. I have this many ounces and this many milliliters. They are equal volumes. I'm just using different reference of how I'm making sense of how much is there. The same thing is true here. I can reference a solution as a percent solution. I can reference it as a molar solution as well. All right, so if we look at percent, this is probably maybe the easiest for you to understand up front. So you'll notice I have a 5% salt solution, I have a 10% dextrose solution, and I have a 4% magnesium sulfate solution. Okay, so I have different solutions here. Well, how much is that? Well, remember, percent is the amount out of 100. So I have a certain number of parts out of 100 parts. Well, that's what that means. So if I, for example, this is the easiest way to do this. If I have a 5% salt solution, all you have to do is go take off the percent and put grams per deciliter. Now, you may not have memorized this, but it'd be a good time to do this. The deciliter is also 100 milliliters. So when I have a 5% salt solution, I have 5 grams per deciliter. Or I can also say I have 5 grams of this in 100 milliliters. So that means if I had a beaker and I put 100 milliliters of it in the beaker, that means I have a volume of 100 milliliters and there are 5 grams of salt in there. So if we go back, okay, to our slide, I can do the same thing for everything else. I can say, okay, with my dextrose solution, hack off the percent sign, put a gram per deciliter or gram per 100 milliliters. So that means in 100 milliliters I have 10 grams of dextrose. I have 4 grams. Okay, and I can do that. It doesn't matter. Okay, so if I have a 0.9% salt solution, that means I have 0.9 grams of salt per 100 milliliters. If I have 10% dextrose solution, I have 10 grams of dextrose per 100 milliliters. Now, it doesn't matter whether I've got 100 milliliters or a whole hot tub full of this stuff. The concentration's still the same. If I fill a hot tub with a 5% salt solution, it doesn't matter how much I have. It just means that whenever I dip out 100 milliliters, there are 5 grams of salt in there. If I have a 10% dextrose solution, doesn't matter. I could have a truck full. Okay? I dip out 100 milliliters, there's going to be 10 grams of dextrose in there. It's just telling me the concentration.